Hello and welcome. I'm James Murphy, and today we're talking about binary search. Binary search, also called bisection search, is an algorithm for finding an element. element quickly in a sorted array. Suppose we're trying to find 7 in this array. Is it in the left half or the right half? The right half, and then repeat. Finally, there's just one element left. That's our 7. Even though it's one of the first algorithms that one learns, it's also extremely important. Analyzing binary search is often the brain branching point for studying things like time complexity complexities of algorithms and big O notation. Here you can see we started with 8 elements, and at each step we ruled out half of them. This idea of ruling out half of all the possibilities at each step is where binary search or bisection search gets its name. This is also where it gets its logarithmic time complexity from. So binary search is useful, fundamental, and simple. And yet, a huge percentage of programmers, even professional programmers, struggle to write binary search. How can the idea be so simple, but the implementation be so difficult? Well, it's not so difficult. You just have to think about it in the right way. The first thing we should decide on is, are we returning the object that we find or the index that it was at? The index itself is a more useful piece of information. We can always just grab the object at that index later. But what do we do if the object we're looking for isn't there? Do we do something like return -1 or maybe raise an exception? Or what if there are multiple valid indices to choose from? With every arbitrary choice that we make, we would have to remember the implementation details that go with that choice. A better way to do it is to rephrase the question so that there's always exactly one answer. So here's how I would rephrase the question. If I were going to add another 7 into this sorted array, where should I put it so that it's the first 7? Notice that in this hypothetical, I'm always adding the 7 into the array. That guarantees the array is non-empty and always contains at least one 7. But if it contains at least one 7, then there is always a unique first 7. The index of that first 7 is the answer to my question. It doesn't matter whether or not the original array had a 7 or multiple 7s in it. The location of the first 7 in the new array is always uniquely determined. If there were no 7s, I would have to put it here to maintain the sorting property. And if there are already 7s, it would have to be the index of the first already existing one. Even if the array were empty, I still get a valid answer. In this case, I would have to insert the 7 at index 0. Notice that 0 is not a valid index into this array, but it still makes sense because the question that I asked was, where should I insert it? And it certainly makes sense to insert it at index 0. The same applies for a non-empty array. Binary search might tell me that I have to put it at the end. As long as you keep in mind this interpretation of what binary search is supposed to return, it's much harder to get confused. I think that far too often, binary search is taught solely as an algorithm that works on sorted arrays. But the array being sorted, I claim, is not actually the property that we're using here. Here, look. I changed some of the elements, and this array is no longer in sorted order. But notice, the steps are exactly the same. What we need is that everything less than 7 is on the left and everything bigger than 7 is on the right. In this array, the numbers have been replaced with the important information. Is this number less than 7? Notice how any trues are on the left and any falses are on the right. So now that we're looking at the relevant data, where do we insert 7 so that it is the first 7? Notice that the answer that we're looking for is the index of the first false. value, or the end of the array if there are no false values. This is the key insight that we need to keep in mind that makes the implementation extremely easy to remember. Squint your eyes and find the first false value. Okay, let's write the implementation. Low and high are lower and upper bounds on where this first false index is. 0 would mean the first value is false, and length of the array would mean that all of the values are true, so we would need to put x at the end. The idea is that we are going to continually increase our lower bound and decrease our upper bound until they're equal. Low and high will meet at the unique index that we're looking for, so we could return either low or high, it makes no difference. We compute mid, which is the closest index to the middle between low and high. Python can represent arbitrarily large integers, so we don't need to worry about overflow. But if you're doing this in another language besides Python, you might have to worry about overflow. In that case, you can represent the midpoint equivalently by writing it as low plus half the distance between low and high. If you write it this way, it will never overflow. Next comes the part of the algorithm that is most often written incorrectly. We need to compare whatever's in the array at the midpoint with our given x, and then update the lower or upper bound accordingly. Remember, we're looking for the first false value, where true or false is determined by asking the question, is this less than x? Well, in this section, the middle value is less than x. It is a true value. Since the value at mid is a true value, the earliest a false value could occur is the next one, which is mid plus 1. What about if we see a false value? In this case, the first false value couldn't be any later than mid because there is a false value at mid. But it could be earlier. There might be other false values before the one that we've found. That means the best we can do is update our upper bound to be whatever mid is. And there you have it. This is a correct implementation. But how can we reason about it? How do we know that this actually gives the right answer? Well, we know that low is always less than or equal to the correct answer is always less than or equal to high, and we do keep updating the lower and higher bounds, but how do we know that they actually meet so that the loop stops? It's enough to show that every iteration, the difference between high and low always decreases by at least 1. If we enter this clause, the plus 1 ensures that low always increases by at least 1. In this clause, we're setting high to mid, so hopefully we're lowering high, but how do we know that mid was actually strictly less than high? Here, we're actually using that integer division rounds down. Inside the while loop, low is less than high, so low plus high is strictly less than high plus high. That means that when we divide by 2 and round down, we'll get something strictly less than high. It's common to take low and high as optional parameters so that if you already have a lower or upper bound, you can make use of that. And of course, don't forget to check that the parameters are valid. And that's all there is to it. But wait, you ask, instead of returning the index to insert a 7 so that it would be the first 7, couldn't I also return the index so that it would be the last 7? Yeah, you could. You could follow essentially the same analysis and get a very similar algorithm. To find where it should go to be the first 7, the relevant piece of information is it strictly less than 7? To find where it should go to be the last 7, you want to know is it less than or equal to 7? In either case, the index that you're looking for is the first false value. You just need to decide on what you mean by true and false. The first one is called bisect left, and the second bisect right. So this one that we already wrote is bisect left. Can you tell me what you need to change in order to make it bisect right? Here's an example. Of how you might use bisect left. For this function, we want to find the index of the first x in the array, or throw an error if there isn't one. Since we're looking for the first index, we'll use bisect left. If there is already an x in the array, bisect left will return the index of the first one. So we would like to just check at that index and see if we see an x. If we don't get back a valid index, to use it. That's Welcome to my list of the top things that Python noobs do. Some of these are actual issues for your code, but a lot of them don't actually matter much. Nevertheless, these things will tip people off to your inexperience, so whether you're an actual noob looking to get better, or if you just want to catch any newbie habits that you still hold on to, let's dive in. Alright, newbie thing number 1, manual string formatting, aka putting things together with the plus sign. Instead, use f-strings. They're more readable, easier to write, and less prone to errors. Number 2, manually closing a file. I can't tell you how many beginner tutorials recommend doing something like this. Open the file, write to it, and then call close. If this write call throws an exception, the file will never be closed. Instead, use a with statement, which will ensure the file is closed even if an exception is thrown. On a similar note, number 3 is using try finally instead of a context manager. I usually see this one from more experienced developers, but coming from a different language. In Python, most resources that need to be closed have their own context manager. Use it. Number 4, using a bare except clause. In Python, keyboard interrupts and system exits are propagated using exceptions. That means, for example, a bare except is going to catch something like the user hitting Ctrl+C. That's almost never what you actually want to do. If you still want to be lazy but you don't want to trap your user in a box, then use an exit capital exception. Or if you want to do the right thing, then catch the actual exception that's going to be thrown. Number 5, thinking the caret means exponentiation. Nope, it's bitwise XOR. Okay, that one's a really newbie one, but I gotta pad the list somehow, right? No. Number 6 is any use of default mutable arguments. Argument defaults are defined when the function is defined, not when it's run. In this case, that means every call to the function is sharing the same list, meaning the second time we call it, it's not starting out as the empty list, it's starting out as the list containing 0 from the previous call. Probably not what you wanted. If you want a mutable default, first set it to none and then check if it's none inside the function, setting the default there. Number 7, never using comprehensions, or if they do use comprehensions, only list comprehensions. A lot of code can be made both shorter and clearer by using a comprehension. You can have dictionary, list, set.
These are very, very quick operations. Just improve your problem-solving skills and you'll be able to pass all your coding interviews. Just solve some linked list questions over here and some tree questions over there, and then you'll be able to derive the edit distance algorithm yourself, just like this Soviet mathematician did in the 1960s. If that sounds ridiculous to you, it's because it is. Let me tell you a little secret. You're not supposed to figure it out yourself. Did you ever watch that episode of Naruto where the exam is intentionally designed to be so difficult that the only way to pass is to cheat? Well, that's the modern coding interview in a nutshell. Let me tell you what I mean. We all learned long multiplication as kids. We all memorized this algorithm. To get the product of these two numbers, first we take 2 times 5, that's 10, the 1 is carried, then we do 2 times 5 over here, that's 10 again. We remember we carried the 1, so it's actually 11. We start all over with the 3 on the second row, but before we have the 0 over here, and then we say 3 times 5, that's 15. Then we say 3 times 5 once again, that's 15. So this becomes 16. Take these two, add them together, we get 1760. Now I know what you're thinking. This is just math. How is it relevant to LeetCode? But please just hear me out. Most people don't care enough to ask, why does this work? They don't care enough to notice that this is the same as writing it out like this. But this is a hard problem, so let's make it easier. This is really just 5 plus 50. This is really just 2 plus 30. Expanding it out, taking 2 times this part, we get this. Taking 30 times this part, we get this. And this part over here, you can notice, is going to be 10 plus 100. This part over here, I'm actually going to rewrite it. I'm going to make it even more simple. Why not? 30, that's too big. I'd rather have 10 times 3 and then multiply that by 5 plus 50. So now just focusing on this part over here, this is going to be equal to 15 plus 150. And so this becomes 110, which it looks pretty familiar over here. This becomes 165, which looks to me like we had that over here. And now it becomes clear why we add a 0 over here, doesn't it? It becomes pretty clear because we just take the 10 out of the 30 over here. This isn't really 3 times these numbers. We just took a shortcut to make it simple for us, and then at the end we'll add that 10. So just like now, I'm going to add 10. I'm going to add a 0 here. This is 1650, and now this is just addition. I took multiplication and turned it into an addition problem. This is called problem solving. And now that I've gone through this, I have at least a chance of discovering long division on my own. Have you noticed that some people are naturally better at LeetCode or just learn faster than others? Well, usually those people come from another highly technical background like math, and they probably already built a lot of problem-solving skills that can be applied to computer science. It makes sense why a mathematician would have an advantage over, say, a farmer, for example. So what can you do to give yourself an advantage? Don't focus on extremes. If you try to memorize solutions for every single problem, which is not easy, by the way, you'll never be able to solve a new problem. If you never look at the solution for a problem, you'll spend 10 hours on a single problem and still won't be able to figure it out. In my opinion, there is an intersection between memorizing and problem solving. You need a little bit of both. If you're going to memorize anything, please memorize the DFS algorithm. It's the single most important algorithm in coding interviews. Memorize the core CS algorithms like binary search, the sliding window technique. And when you get super familiar with these core skills, you realize that most LeetCode problems are just about identifying which core algorithm to use and then applying it to the specific problem. In other words, in terms of coding interviews, problem solving is all about pattern recognition. A reasonable approach to coding interviews would be to first learn the core algorithms needed. It's fine to look at solutions. You're in the learning phase. Just like an ML model, you're taking in training data. After that, you should try to apply your knowledge. If you were able to derive the solution to all these problems by yourself, it would greatly improve your problem-solving skills. But that's obviously not realistic. But consider this. If you're trying to figure out the edit distance algorithm, you would have a much better chance of doing so if you first solved the longest common subsequence problem, because it has significant overlap. And of course, that's not something you realize until you've actually solved these problems, which is kind of why I've organized them in this list. You don't
Okay, so to get a job in software, we have to study legal. Okay, so to get a job in software, we have to study leak code, we have to do system design, we have to build projects, we have to do object-oriented design, we have to do take-home projects. Like, which one should we be focusing on? Today, I wanted to give you a simple flowchart of what you should focus on given how much time you have before your software job. And today's video specifically is going to focus on people with 0 years of experience in the software industry, because that's the situation I was in when I started my first journey. This is my flowchart, and let's start with at the top of it. The most important question to ask is, are you getting interviews? Which is probably the most frustrating part of this whole process for some people. Let's say you're not getting interviews. So how do we gauge that we're not getting interviews, or we're just not waiting long enough for these responses from companies to come back? I would say, as a general rule of thumb, if you've been applying for jobs every single day, but you haven't gotten a single response in over a month, it probably means it's time to change something up. So you should probably be doing a few things. The first is to take a look at your resume. When I came out of college, this was my resume, and it was absolute garbage. But over time, I was able to shift things around and finally make it into something that was, somewhat presentable. One thing I would strongly recommend is to go to r/engineering resumes and look at the sidebar and read all the information that's contained in there. If you're interested in a deep dive into what is going on in the sidebar, I'll probably go through that in a future video. But for now, here are probably the main tips and takeaways that you can take away in like 5 seconds. Basically, for every point on your resume, you want to quantify it with something like the XYZ format or the star format. Basically, you accomplished X by the measure Y, resulting in Z. And that should be every single bullet point. You should list all of your skills at the top, followed by your work experience, followed by any projects you have, followed by your education. Make sure your formatting is good and it's not confusing and it's readable, and make sure the entire resume can be filled up with some kind of information. Because again, if you look at my first resume, it was sad. It was like half a page. And if you look at the points on my resume, they didn't make any sense, right? They didn't tell you like what I actually did or what I actually did that made an actionable impacts on the companies that on my resume. Is that you work on for a cyber stats, put it into a database and serve it in a web application, and that can be your side project. If you don't have that much experience, most online for everything you can. possibly think of. Take anything that you could possibly be interested in. Take any type of hobby you have. Say you watch basketball, you watch the NBA, right? Download some NBA stats, put it into a database, and serve it in a web application, and that can be your side project. If you don't have that much experience, most people during interviews are going to be talking about your projects, and they're going to be seeing like, are you bullshitting you doing this project? Did you just make some shit up or copy some shit off of someone else on GitHub? So it is important to find a project that you're passionate about. Okay, so back to the flowchart. If you are getting interviews, what type of company are you trying to apply for? The big question is, are you shooting for FANG level companies? If you are not, this is important. You don't need to grind a ton of lead code questions, but you do need to grind basic string manipulation questions and basic array type questions for coding interviews. The reason being is that when I was coming out of college and interviewing for a lot of places, they didn't necessarily ask me like complicated lead code questions. Like I wasn't balancing trees or traversing through graphs or doing dynamic programming, stuff like that. But I was asked stuff like, you know, reverse a string or do some string manipulation, remove like every third letter in a string or something like that. And these are pretty easy questions, but they can get progressively harder if you haven't really practiced them. So string manipulation questions and array questions are very commonly asked by companies that are just trying to assess, okay, can you code and did you pass like a CS 103 class or something? What I recommend here is to go to the Neat Code 150 and just do the first few sections. The first few sections about arrays, about hash maps, about binary search, about using multiple pointers. These are things that will actually be asked all the time for companies that aren't FANG level interviews, and they will serve you well. if you understand them, and especially if you understand how to use the tools that he's teaching in LeetCode. So back to the original topic. Are you shooting for FANG level companies? If you are shooting for FANG level companies, then ask yourself, are you pressed for time? If you are not pressed for time, back in, which is you want to do a little, right? So all of the above. Basic point there. And where you can list to study kinds of questions these companies a whole, you're going to get every question wrong.
Hi, and welcome to another or a better refresh.
Thank you, Rakuten. Really good. But I also using IntelliJ for Java. Not everything will be mounted. There are some cornerstones that I need to make sure that is set before I really jump in my search and replace. Oops. Okay. And then of course the third one is the source control. If you can give you some basic pull, push, and diff, that will be good enough. That's my cornerstone. To know, but I know that I need to learn all the strokes, right? I'll stuff just to not annoy my fellow deaf. Okay, there are other things for ease of typing. So okay, next one. Okay, project file navigation. Okay, let me go through. Okay, they are also quite straightforward. I have to be able to jump from current out the tree. Combine. Because I think it's yeah, okay. Hopefully it will not what else? Know that it's very
add image because sometimes I work in remote and in remote environment it's better to use add image for Linux and it's pretty straightforward. Right, so it's still just now we talk about words. Let's say we jump one word. So one key is one word, right? One time, but you can jump multiple times. So it's the reason that I say it's programmable because it works like a function. Let's say if I type. So you can see on the left, there's a install a Vim in VS Code. That if you have an environment that has a Git install and all the
this slow, sorry, let's say I'm working on my color scheme, then keep all the file that with TXT. Then it will reduce it back to like 20K. Then I slowly filter. Then I know that what's up. I seldom use the motion, I'll say, because every time you want to count, it's very taxing for me. Let's say I want to jump 5 words, then I do 5W. It's a bit too much. So I am done.
A really nice, simple, and easy to use interface that you can learn quickly and can make your life a lot easier when working with Git on the terminal. It also integrates really well with NeoVim, which is something that I was especially looking for. In this video, I'm going to show you guys how to get started with LazyGit, is the most frequent updates. If you're on a Linux or a blog, which I use to make blog post out.svelte file, and I'm just going to add a console.log here that says hello there. And save. I'm going to close NeoVim with :Q and enter and open up LazyGit again. Now you'll see that this layout.svelte file has a modification. That's why it has an M next to it. Within a pane here, you can navigate with your down and up arrows or J and K, just like in Vim or NeoVim. On the right hand side, we can see the modification that we made to the file. If you want to scroll through this main panel that shows the modification, you can do page down and page up on your keyboard. You can also scroll with your mouse. Now let's say I want to stage this change. If you ever want to see the available key maps you can use the question mark. And this will show you all of the different key bindings for the pane you're currently in. If you want to filter through these, you can use the / like in Vim or NeoVim, and I want to stage, so I'm going to look for stage. Nice, so you can see here we need to use the space key. If you want to exit this search mode, you can press escape, and I'm going to do escape again to close this window. So as you saw, we can press space and stage our change. If you want to unstage it, you can press space again. I'm going to do Control-C to close LazyGit again, open up NeoVim, and I'm going to look for a different file. I'm going to look for page.svelte and add another console.log here. Hi, and comment out one of these tags. Again, I'm going to save this, close NeoVim, and open LazyGit. And you can see now that we have 2 different files that have been changed. Again, I'm navigating through these with J and K. Now let's say that instead of wanting to stage a single file by pressing space, you want to stage all of the changes. Again, we can do question mark, and down here you'll see that with the A key, we can stage all. I can go to the specific line we want to stage and press space and space again. And if you want to undo that, you can press tab to go to the right hand side and press space to your remote. Again, I'm going to do question mark / and look for push. So as you can see here, you can use capital P to push changes. Now if you go to the commits pane by pressing 4, you can see the commit we just made, and again we can scroll through the contents of this main panel with page down and page up. Now let's say you want to push these changes to your remote commit. And I want to show you guys how to resolve a merge conflict. So I'm going to press 3, go down to main, press space to change into it, close LazyGit with Control C, open up NeoVim, and I'm going to change this to hello from main branch. And this is the same line that we modified in our example feature branch. I'm going to save this, close NeoVim, open LazyGit again, press A to stage all, press C to create a new commit. I'm going to call this example commit from main branch. Now I'm going to go to pane 3, do question mark / and look for merge. And as you can see here, we can use capital M to do a merge. I want to merge my example feature branch, so I'm going to go down to example feature branch and press Shift M and enter. And as you can see here, we have a conflict. We can view conflicts by pressing enter. I'm going to go down here to page.svelte, which is where we have Hey guys! In today's video, I'm going to be sharing with you how I set .tmux.conf. That should create the file for sessions. To create a new tmux session, we can do tmux new-s and then the name of the session. Let's just call it session. After we run that, now we're within the tmux pane to this window. Tilde a plugin, but we need a plugin to go up, Control J to go down, Control duration. The next thing I want to show you is window. Give them for my code and directory that new tmux panes and windows will start. For example, I'm going to do the same in the in line 23. I'm going to add the following.
Tmux is perhaps the one piece of software that's had the biggest impact on the way I write code. Out of the box, however, Tmux can be difficult to look at. It requires a little bit of configuration to really get productive with. In this video, I'm going to explain why, so make sure you have that as well. To install the Tmux package manager, you use a collection of one or more windows managed as a single unit. You can have any number of sessions open at one time, but typically only attached to one. Each session has a single active window. Windows are a container to one or more panes. You can think of windows as tabs in browsers or other software. Each window has a currently active pane and allows you to switch between any of the panes that it manages. The windows in the session are shown at the bottom of the screen, as well as which window is currently active, as marked with an asterisk. Panes are splits in the window and represent an individual terminal session. There will only be one active pane at a time that you'll interact with. In this window, I have 3 panes which have been created by splitting the window horizontally and vertically. My current active pane is the one on the left, which I can enter commands into. To enter commands to Tmux, you need to use what's called the prefix key. This is a key combination that you use before the actual command itself. The default prefix is Ctrl and B. To create a new window, you press the prefix followed by the C key. As well as creating the new window, this command will also set it as your current active window for the session. To change between windows, we pass the prefix and the window our current pane into a window by using the prefix and using the tmux element. I like to use a package called vim tmux, setting the following line. This sets tmux a plugin for tmux as well, which we can install mouse wheel to scroll through mouse or by entering copy mode, which is through
You need to start using tmux right now. Check this. We didn't stop them, we didn't kill them, we just detached. How do we see those sessions? This command, tmux ls. Just like you list your files, kind of killer, right? Let's do it again. Control B, %. Bam! Left, right. Which way do you want to go? Let's try up. Just gonna hit the up arrow, directional arrow, Control B, and just right here, a hacker. I mean, just imagine you're doing an nmap scan, you switch out, and you do metasploit. You jump out, you're running subfinder or some other subdomain enumeration tool. Have those running detached. I mean, it's cool. Now we have all these panes, windows, and sessions. Let's talk about killing. How do we kill them? How do we get rid of these guys? We've created them. We've created our monster here and be dangerous. But there's one more thing if you want to stick around. There is something called copy mode, which makes copying text ridiculously easy. Now notice what's happening here. Notice the top right, we have like a special little 00 menu. We're in copy mode, and when I release, we're done. That's probably the easiest way to copy with tmux. That line of config, the set g mouse, whatever that was, we can easily just highlight anything and then just paste it. That's super handy. But